Chapter 6 practice test. So write those down, please. Okay, is that better? Alright. So I'll read them off, okay? It goes a little quicker that way. 1 is 720, 2 is 2520. See the margin. You won't have a question like that on the test, so don't worry about that. X is 2, Y is 90. And then number 4, it's angle D. Number 5 is line segment DC. 6 is line segment BD. Number 7 is 7. Number 8 is 13. Number 9 is 18. Number 10 is 32. Okay, number 11 is C, which is 13. There won't be a multiple choice on the test, but that one happens to be multiple choice. Okay, number 12 is 5. Number 13 is 122. That's correct. Number 14 is 90. Number 15 is 12. Number 16 is 62. Don't worry about 17. Let's go to 18, which is 109. Number 19 is 6. Number 20 is 71. Get my finger out of there. Number 21, it's 21. How about that? Oh, 22 is 22. Wow, 2 in a row. That's 3 on that whole thing. Where the question, I don't know. Dumb stuff like that. I told you I was a geek, all right? I mean, not that I had to prove it to you. I think you already knew that. Anyway, 23 is 34, and then determine whether it's a parallelogram. Is this a parallelogram, 24?
Yes.
Yeah, both pairs of opposite sides are congruent. Opposite angles are congruent. And 25, is that a parallelogram? No. Okay, now, if the opposite sides were all equal, right? If both pairs of opposite sides were equal, then it would be a parallelogram. This is not a parallelogram. Oh, there's the answer right there. There you go. Okay, that's the answers to the practice test. All right, let's go over just a couple questions from the practice test, the ones we just read off, and then we'll. I got a microphone right here, and then I'm going to go question by question what's going to be on the test. Okay, I did that in the other period, in the other class, and it took most of the time. So let's get through this quickly, and then we'll see what's going on. So like number 7, right? So I mean, once you do number 7, you can do 7, 8, 9, and 10 because they're all the same, aren't they? All right, so number 7 says 900. What are they giving you right there? It says the measure of the interior angles, right? Angles, which means it's what? Plural, right? It's 900 degrees. Does that mean each angle is 900 degrees? No. What is this 900 degrees? It's the what? It's the sum of the angles, okay? And it's of a regular polygon. Of a regular polygon. Right? Well, do we know a formula for the sum of the angles of a regular polygon?
Yes.
What is it? No, that's not it. What is it? It is. It's n minus 2 times 180. Okay? Now, Caitlin, you were on the right track, but it wasn't the answer to the question that I had asked. I said, what is the sum of the angles of a regular polygon? You said divide by 180. That's not really the formula. But look, this is the sum of the angles of a regular polygon equals this formula right here. Well, what do I know on number 7? I know the sum of the angles of a regular polygon, don't I? So I'm going to put that right here. And now I can just solve for n. Right? Probably this is why you're going to come up too short, because I don't think you put the minus 2 in here. Watch what I'm going to do. You could distribute if you wanted to. I'm going to do this a little bit easier. I'm going to just divide by 180. Couldn't you do that? All right, and so that cancels out. What's 90 divided by, it's 5. Okay, so 5 equals n minus 2. But I got to solve for n, so what do? Add 2 to both sides, and so what's n? It's 7. That means on a 7-sided figure, the sum of the angles of a 7-sided polygon is that. Okay, actually, I don't even have to say regular on this, do I? Because what does it ask you? It just says find out how many sides you have, right? So really, the fact that this is a regular polygon doesn't really make any difference. Okay, it could be just a normal, non-regular polygon, right? All the angles don't have to be equal to each other for you to figure out that there's 7 sides to this. Yes, sir.
Did you do one with the exterior?
With some of the exterior.
Yeah, how do you get that? I know it all adds up with 360.
Right. Like, would you use exterior angles to find this answer right here? Or just do another problem with exterior angles? Oh, okay. I thought you meant how does that relate to this? I don't know. Find one. Is there one that
I'll find one you can
like
do.
1 and 2?
Okay.
No, actually.
Yeah. You just take the
Yeah, on that one, it's just n minus 2 times 180. That was really easy. 1 and 2. Is there another one like that? What about the study guide? We did one in the other class from the study guide, like 11 and 12. No, not even that one. Here we go. 14 and 15. Let's do one of those. I know, but we can use exterior to find the answer to number 14. This is number 14 from the study guide, not the practice test, the thing we just went over. Okay, this is from the study guide. All right, number 14. And they tell you, it says the measure of an interior angle of a regular polygon is given. Now, this is important that you know it's a regular polygon. This is what I like to do on this, just to make sure that I know I have a general idea of what I'm trying to do here. It's a regular polygon. These two sides are equal. I didn't draw the rest of it because I don't know how many sides I have, because that's what they're asking for, isn't it? I think it is. Yeah, find the number of sides in the polygon. I don't know how many sides there are, so I can't like complete this, can I? Because I don't know how many sides. But I'm just going to do like a little blow-up portion, right? I just kind of zoomed in. Does that make sense? To just one of these corners, because one of these angles is going to be the same as all the other angles, isn't it? All right, because it's a regular polygon. So if they tell you that this is 135 degrees, they say how many sides are there? So a couple ways you could do this. When I taught this lesson to you, I used a formula that went like this. It went 135, and I'll tell you what, I'll show you where I came up with that formula. I don't think I showed you when I taught the lesson on YouTube. This is each interior angle, and this is the sum. Now, that right there would not be true, would it? Because what does this represent? That represents all the angles added up. Is 135 all the angles added up? No. Okay. But watch this. This is each interior angle. If this is a regular polygon and this is the sum of the angles, what can I do to find each interior angle? Divide it by how many sides I have. Do you agree? This is the sum of all the angles. This n represents how many sides or how many angles I have. Does that make sense? So if I add up all the angles, divide by how many angles that I have, I'm going to get each one of those. Yes? No? Does that make sense? I don't know a better way to explain that. This is the sum of all the angles. This is if I add up all the angles, the 135, 135, 135, 135, right? How many I have. I don't know how many I have. That's why I used n. Okay? So that's the sum of all the angles. If I divide it by what each angle actually is, that's going to give me, or I'm sorry, but if I divide it by how many angles I have, which I don't know, that's going to give me 135. Okay? Jacob, you getting all this? Sure? Okay. Now watch what I can do with that n. If I was going to do some math, how would I get rid of that n? I'm going to multiply both sides by n. And what is, whoops, let's try this again. Oh, sorry. Let me just scooch it over like this. I'd multiply both sides by n. Multiply this by n, multiply that by n. That's the formula that I gave you when I taught the lesson to you. Do you remember that? That 135n or whatever that number was? That's okay. You could do it that way. And you can go through the math and solve if you wanted to. You can distribute the 180 through, get the ends on the same side. I'm not going to do the math for you. Let me show you what I think is a little more of a streamlined, easier way. Okay, and that would be to look at the exterior angle. Okay, this is what I was talking about by using the exterior angle to find out how many sides I have. If this is 135, what would the exterior angle be equal to? Be 45. How'd you get 45? That's right, 180 minus 135, because they're supplementary, aren't they? Now remember, what do all the exterior angles add up to be? 360. So that's real nice. Exterior angles are really nice because they always add up to the same thing. It's always 360. Does that make sense? That's a little bit easier. So if they all add up to 360, what can I do to find out how many angles I actually have? Divide 360 by what? By 45. If I divide 360, remember, all these angles add up to 360. If I divide the sum of the angles, 360, divided by one of the angles, which is 45, that's going to tell me how many angles I actually have. Does that make sense? And then that's nice and easy. And I think that's, is it 8? Is that right? Yep. And that's 8. And so what does that mean? That means there's 8 exterior angles, which means there's 8 interior, which means there's how many sides? 8 sides, right? There's just as many exterior angles as there are interior angles as there are sides in that particular polygon. Does that help a little bit? Okay. Don't you like this math a little bit easier than this math? Yeah. Okay. It'll work out either way. All right. I'm not going to take the time to do this, but you can. And n will equal 8 if you did this. But I like my way. It's not really my way, but I like doing it the exterior angle way. It just seems like it's a little bit easier. Eventually, it's going to come out to the same exact answer. All right, enough of that. Let's go question by question on what's going to be on the test. Hey, you ready to write this stuff down? Oops. 1 to 3 are kind of the same problems. They're kind of like this, actually, where it's kind of those word problem things. I don't know how to describe it any better than that, where they, it's all about the sum of the interior angles. If they give you each angle, tell me how many sides they have, or if they give me, each interior angle, or sorry, if they give you like how many sides, what's the sum of the angles, what I mean? All those things. So we did a couple of them already. So it all has to do with 1 through 3, all has to do with the sum of the angles of a polygon. And they just write it out in a sentence, right? They give you a sentence and they ask, how many sides are there? If each interior angle is this, how many sides are there? If the sum of the angles are this, how many sides are there? If there's this many sides, what's each angle, okay, on a regular polygon? Or if this many sides, what's the sum of the angles? You get the idea? Okay, that's 1 through 3. I don't know how to explain that, but you can figure it out. Okay. Number 4, it's basically, I'll tell you what, let me scooch over here a little bit. Give me a second to find this. I just want to give me a nice parallelogram. It'd be just easier finding it, copying and pasting it. All right, there's parallelogram. And let's make it like this. Let's just go through some basic stuff, okay? So really, this actually works for like 4 through 7, to tell you the truth. So let's put, oh, there we go. Basically 4 through 7. If you know all this stuff, what are some of the basic things we know about a polygon? Or a parallelogram, sorry. Ugh, clicking on all this dumb stuff I don't need to be clicking on, sorry. All right, what do you think? By definition, what do we know is true about some sides on here by the definition? What do you think?
The opposite sides are congruent and parallel.
Okay, only by definition they're parallel to each other, okay? Not congruent. But by definition, the opposite sides, both pairs of opposite sides are parallel to each other, okay? Now we had a theorem that said the opposite sides were also what? Congruent to each other. So we knew that. We knew something about the angles. What do we know about the angles on a parallelogram? Opposite angles are equal. Both pairs of opposite angles are equal. So these two angles would be equal and these two angles would be equal. Make sure you know that for number 4 on the test. And make sure you know the opposite sides are equal. Okay, all that stuff that I'm showing right here. All right, you're going to have to do some stuff. Now, 4 through 7, what they're going to do is they're going to give you like this side and this side. They're going to say solve for x, right? One of the sides would be like, I don't know, 3x plus 1. The other is going to be like 4x minus 7, or I don't know, something like that. You follow me? So you just set them equal. No big deal. So that's simple, isn't it? What about the angles? What if they give you an angle here and an angle here, like in terms of x? What would you do with those two? Set them equal to each other. Then solve for x. No big deal. Easy, isn't it? What about this angle right here? Let's label it AB. What about A and B? Are they equal to each other? Well, what are they? They're supplementary to each other. Okay, remember parallel lines cut by transversal? They're same side interior angles. They're supplementary. So angle A plus angle B would add up to be 90 degrees. Agreed? Don't set them equal. That's what a lot of people do. A lot of people, what did I say? Did I say 90? I'm sorry, 180. I meant 180. All right, so angle A plus angle B equals 180 degrees, not 90, sorry. Oh.
The other angle next to A, would that be
This one?
supplementary when angle C?
Yes, A and C are supplementary because, again, these two are parallel, right? A, B, and C, D are parallel, and this is a transversal, so these are also same side, or I used to call them same side interior, but the book calls it consecutive interior angles. Everybody with me on that? Okay. You also had some, what are these things called? Diagonals. What do we know about the diagonals of a parallelogram? They bisect each other, absolutely. So they bisect each other. Let's do this in a different color. I'm still going to use one tick mark just so I don't use 100 different tick marks here. So that means that and that are going to equal, and this one right here and this one right here are going to equal. You with me on that? Are they necessarily equal to each other, the two diagonals? No. When are the diagonals equal to each other? When it's a more general rectangle, because a square is a rectangle. But any rectangle, the diagonals are equal to each other, okay? Do these diagonals bisect these angles on a regular parallelogram? Not a regular, on a normal, everyday parallelogram. No, they don't, okay? These angles are not being bisected. Excuse me. Thank you. Got that on tape, or whatever you call it, on digital. What about this angle in here? Is it a right angle? For rhombus, it's a right angle. Is this a right angle on a normal, everyday parallelogram? No, it's not. What else? That's about it. So if you know all that stuff, you can do 4 through 7, no big deal. We good? All right. 8 and 9 is one of those where they ask you, is this a parallelogram or not? You don't have to give a reason. You know how in the book I didn't make you. The book says, what do they say? Not supply a reason. What do they do? Justify your answer, right? They always say justify your answer. I'm not going to make you do that on the test. I'm just going to make you just tell me if it's a parallelogram or if it's not a parallelogram. All right? So, did you get your quiz back? I gave it back yesterday? Okay. Remember we talked about that yesterday? About that quiz? What was a common mistake people made on that? I think it was the first problem, wasn't it?
Yeah.
Didn't I do this? And then this? And almost every single person in here said, yes, that's a parallelogram. But it's not a parallelogram. I think we even talked about this, right? I said this side could go like this. You can make a trapezoid out of it. And there you go. So it's that kind of stuff. Okay, so that's 8 and 9. You just have to say, is that a parallelogram or is it not a parallelogram? That's it. Easy. Now, what would make this a parallelogram?
The top.
Yeah, if I made the top and bottom parallel and equal, if the same two sides, are parallel and equal, then yeah, that would be a parallelogram. Okay? We good? Let's keep moving. I put a lot of stuff about rectangles. I don't know why, but 10 through 15. 10 through 15 is all about rectangles. So let's talk a little bit about rectangles. So there's a rectangle. Let me put some diagonals in here too, because we're going to be talking about the diagonals of a rectangle. Alright, and might as well just label this so I don't say this angle and that angle. I can actually name it. Alright, there we go. And so now, a rectangle, by definition, what is a rectangle? It's a parallelogram that does what, Chad? What's that? Well, answer it anyway. Yeah, just tell me by definition, what makes a rectangle different than a regular parallelogram? A rectangle. Nah, now you're giving me properties. I don't want that. I want by definition. Jared. Yeah, all these angles are right angles right here, okay? It has 4 right angles. So it's a parallelogram with 4 right angles. That's by definition. All right? Now we can start talking about some properties. Now let's don't talk about the regular properties of a parallelogram. We already know the opposite sides are equal, the opposite angles are equal, the diagonals bisect each other. But what's different about a rectangle that's not true about an everyday parallelogram? Okay, Nathan, tell me, give me one. The diagonals are equal to each other, absolutely. So AC would equal BD. Good. Now, if that's true, if they're equal to each other, they also bisect each other, don't they? Because it's a parallelogram. So watch. AC and BD are exactly the same. They're both being bisected or split in half, right? In 2 equal parts. So what's true about AE and BE and CE and DE? They're all equal, aren't they? All right. All 4 of those are equal to each other on a rectangle. Noel, give me something else. Go ahead.
Like, you know, angle A and B, like the top part of angle A. Like
This bit? Yeah.
And then the bottom part of angle B, like what's the relationship?
The bottom part of D. Like BDC, you mean?
Yeah.
Okay.
What's the relationship with that?
Well, let's think about this. All right, let's think about this. I've got these 2 equal to each other, right? So this angle must be what? Equal to that angle. Would you agree? And then these 2 are equal to each other, so that angle must be equal to that angle. Does that mean all 4 of those? Right, because isosceles triangle theorem. Good. Are all 4 of those angles that I marked right there equal to each other? They are actually. And let's now. I'm not going to require you to give this, an explanation on the test or anything. But I always think it's a good idea. What's true about this angle right here, and this angle right here? They're congruent to each other. So these 2 triangles are what? Side, angle, side, side, angle, side. These 2 triangles are what? Congruent to each other. So that means all the corresponding parts must be what? Congruent to each other or equal to each other. That's right. Yeah, it's CPCTC. You're exactly right. So what does that mean about this angle right here? BAC, we'll call it, and this angle right here, BDC. They must be equal to each other. What about these 2? They're equal to each other. So actually all 4 of those actually are equal to each other, aren't they? Okay, does that make sense?
ADB and all the rest of those.
Yep, and so this and this would be equal basically for the same reasons. They're just different triangles, right? Now, these 2 triangles here and here are not equal to the top and bottom triangle. You follow me? Not equal, but congruent. But this one right here, AED and BEC, they're congruent to each other. And the same reason why these angles are equal. Would you agree? All right, so you know all that stuff. What else about a rectangle do we need to know? I think that pretty much sums it up, doesn't it? I think so. All right, so that's a lot about rectangles. Let's go on to something else. Let's go into a rhombus. Actually, let me grab a rhombus over here first. I got a rhombus sitting here. There's a rhombus. Yeah, I pre-drew those a couple years ago, and I stick them off to the side so I don't have to draw them every single time. I just have to copy and paste. Yeah, well, every once in a while, I figure it out. Come on, if I could grab the dumb thing. There it is. Alright, let's look at this. There's a rhombus. Now, by definition, we've asked you this already, but by definition, what's true about a rhombus? It's a parallelogram with what? Now, you're giving me properties. By definition. That's not by definition. Good. It's a parallelogram with all 4 sides being equal to each other. Okay, that's definition. That's definition of rhombus. Now, those other things you're telling me are definitely properties of a rhombus, but that's not by definition. Okay. You need to stand up and take a stretch or anything. No, I'm looking right here. Yeah. Because your eyes are closed like the last 5 minutes. Okay? Well, your eyes are still closed whether you're sleeping or not. Your eyes were closed. Open them. I want to see them. Yes, ma'am. Oh, I don't know. Let's see. It's only 2 of them, 16 and 17. All right, so there'd be 2 questions about a rhombus. Now, again, let's go through here and let's mark some stuff. So we know by definition that all 4 sides are equal to each other. That's different than a normal everyday parallelogram. Do you agree? Again, I want to see things that are different about a rhombus compared to an everyday normal parallelogram. Somebody said something about this angle in here. What is that?
It's a right angle.
It's a right angle.
Yeah.
Okay? Make sure you know that. That's very important. A lot of you guys missed that on the quiz. We talked about that yesterday, but I want to reinforce that. Are the diagonals equal to each other?
No.
Not necessarily. They bisect each other.
On every rhombus. Let me say this. There's either yes or no. On every rhombus, are the diagonals equal to each other? No. Now, there is one certain situation if the rhombus was a square. Okay, but on every rhombus, are they equal to each other? No. They still bisect each other because it's a parallelogram, but the diagonals do something that nothing else, no normal rectangle or parallelogram do. What is that? They bisect the angles. So this angle and this angle would equal each other. Now remember, big angle B and big angle D are equal, aren't they? So if I bisected angle B and I bisected angle D, I'm taking the same angles and I'm splitting them both in half into 2 equal parts. So all 4 of those are equal, aren't they? Okay? And then I could do this as well. So I could say that these 2 are equal to each other, and they would be equal to these 2 down here. Okay? Yep, and look, you've got a right triangle here, don't you? We'll call that E. So AEB is a right triangle. So if I told you this was 3, and I told you that was 5, without doing any math at all, could you tell me what BE was equal to? 4, because it's a 3 what? 4, 5 triangle. Okay? Yeah. No, 12. No. 5, 12, 13. So if I told you that this was 5 and this was 13, what would this be? This would be 12. Okay? There's other special triangles. I went into it a little too much yesterday, but I think it's helpful. You know, you may use it, you may not use it. Who knows? Is there anything else? What's true about this angle right here? That's angle BAE. And this angle right here, which is ABE. What's true? They are good. They're not supplementary. Cole said it. What? Complementary. They do what? What's complementary angles? They add up to 90 degrees. Okay? You got that? You guys writing this down? Be a good idea. All right, so that's about a rhombus. There's only 2 things. Now, what was the last section about? Trapezoid. Oh, I got a trapezoid.
Do you have a kite?
I do have a kite. See, look, got kites and trapezoids and all kinds of crazy stuff. Let's just use this one. I even have a isosceles trapezoid. But for some reason, I'm gonna have to revise my test a little bit. I think I put too much rectangle stuff and I could put a few more other things. On this test, I don't even have stuff about kites and whatchamacallits. What was the other thing? No, just kites, I guess. That's what I'm thinking.
Do you have squares on here?
I don't think I have a square on here. Well, that's what I'm showing you. This thing right here. What's that? It's trapezoid, okay? And it's not even an isosceles trapezoid. If I had more questions, I'd probably put a couple questions about an isosceles trapezoid. I might put a couple kite questions on there. For some reason, I just don't have them. I made this test up a while back. I could probably revise it for next year. If I would have seen this a couple days ago, I probably would have changed it up a little bit. That's okay. It's still enough information on here to get to know if you know this chapter or not. If this is a trapezoid, tell me something, by definition, tell me something about, I don't know, a couple of the sides here. Kaylin? Good. Exactly one pair of parallel sides. All right, that means one and only one pair. So only two sides are parallel to each other. If I call these the parallel sides, what do I call that on that trapezoid? I give it a special name. Do you remember? The bases, okay? And what would I call these two non-parallel sides? The legs, okay? Jimmy, what do you got? Well, if it was isosceles, the base angles would be equal to each other. Okay, so this angle here, well, let's name this again. I'm not being very creative with my names, am I? But if I name this ABCD, D and C would not be equal to each other. Now, if this was a, what I say, a isosceles trapezoid, then they would be equal to each other. But there is something I can say about the angles, though. Tell me something about angle A and angle D. They are supplementary because look, I got two parallel lines cut by transversal. They're consecutive interior angles, aren't they? Which means they're what? Supplementary. So A plus D is equal to 180. Is there any relationship on a normal everyday trapezoid between angle D and angle C? There's really not. Okay. Now, what about all four of them? They add up to 360. Good. Okay. What I'm really concerned about is this. We talked about if I took the midpoint of this leg and I took the midpoint of this leg and I connected those two midpoints, what do I have? A midsegment, right. So the midsegment connects the midpoints of both of the legs, the non-parallel sides. Everybody with me on that? So if this is the midpoint, we'll call this X and Y. Tell me something about AX and DX. Yeah, they got to be equal to each other because that's a midpoint, right? Splits that into two equal parts. What about Y right here? What does that do? That's a midpoint. So tell me about these two segments. Yeah. Are they necessarily congruent to these two? What if it was isosceles? Yeah, they would be, right? But if it's not isosceles, they're not equal to each other. These two are equal. These two are equal. You follow me? What about the midsegment, XY?
Parallel to AB.
It is parallel. That's good. And Jared, what'd you say? Okay, it's 1/2 the sum of the bases. Or give me one word that you're probably used to saying. It's the, starts with an A. We mentioned it. Now, what'd you say, Jared? The sum of these, right, and half of it. Right? Then you say you add these two up and take half, which divide by 2. So if I take two numbers, add them up and divide by 2, what have I just found? I found the average. Remember me saying this? Almost positive I said that on the video. Okay? So that's a nice, easy way to think of it. This mid-segment right here is the average between those two bases. So if this was 3 and this was, I don't know, 17, we'll go crazy. All right, 3 and 17. How would I find XY? I just find the average. How do you find the average of two numbers? You add them up and then divide by 2. So that's 20 divided by 2, which is 10, and that would be 10. Now, that was pretty easy. What if they do this, though? What if they gave you the mid-segment in one of these? How would you find this one right here? Now, look what we did. We added and then divided by 2, didn't we? So we're going to go completely the opposite on this one. Colton, what do you think?
You would multiply the midsegment by 2 and then subtract.
That's exactly right. Okay. Now, if you don't remember that, you could always set up a little algebra problem. Okay. By the way, what did Colton say? He said multiply this by 2 and then subtract this. Does that give you 17? Yeah. Multiply by 2 is 20 minus 3 is 17. That does work. If you didn't remember that little, it's not really a trick, but if you didn't really remember that method, you could always go a plus 3 divided by 2 equals 10. Isn't that the formula? Right? You add the 2 up, divide by 2, and it's equal to the middle. And you're going to get the same thing, aren't you? Multiply both sides by 2, subtract both sides by 3, and there you go. That's 20 minus 3, which will be 17, just like we said. We good? It's basically your test right there. All right, so there won't be any surprises. I don't like to surprise you on these tests. but you're going to have to know. You're going to have to be able to do a lot of algebra. A lot of this stuff that we did up here, when I'm saying, okay, know all this stuff, you're going to have to be able to like solve for x. Set things equal to each other, solve for x. Add things together, set them equal to 90. Add things together, set them equal to 180, or whatever the case is. You're going to have to know those relationships, all right, and you're going to have to be able to solve for x. Sometimes it's not just solving for x, it's solving for that x and then doing what to it? Plugging it back in, right, plugging it back in to find a certain angle or side, okay? He wasn't sleeping, don't bother him. Okay.
I've been seeing a single classroom.
All right, there you go. Hope that helped.